There we go. It's 9/23/08, and I've been testing IR remote receivers, specifically this one I got from allelectronics.com. Sorry, let me clear that out here. Kind of hooked up to an Arduino board right here. It's really simple. You just power it, and then there's one signal line, pin 1, will take serial data in. I took a very simple little snippet of code that someone else made on a website just for testing purposes to make sure I could get some signal in. And LED 13 right here will flash every time we get some signal, and we can test it with this Xbox remote here, and you can see that, well, maybe you can't. Those little flashing blinkings are the signal it's receiving. The way it works is it runs at 3800 kilohertz, and pulses will be sent out at 3800 kilohertz and modulated. Oh, that's my dog. Modulated by duration, so you'll get 2 millisecond pulse with so many pulses in it. Depending on the duration or the combination of durations, it signifies exactly which signal is coming in. It's hard to do in light, so I'm going to have to move this light a little bit because there's a natural IR component to it. Oops, there we go. You know what, it's easier to just turn it off. Okay, so ooh, you can see the LEDs better. There you go. See, so you're receiving signal there. Let's try this remote. This is just a standard TV remote. There we go. This one works a little better. So, what I want to do with this, and that's horrible backlighting. What I want to do with this is send out a steady stream of pulses from each base station I have, from just a little IR LED, probably from an Arduino. I might do another little circuit I found it designed with a little timer circuit, but probably just straight off the Arduino. And each base station is going to have its own durational pulses, so that's one way to identify the base station. And the controller will pick up on those depending on which one you point it at. And the way I'm thinking about filtering it is if you run the IR through a lens and put it at its focal point, you should get pretty much a flat stream of beams about as wide as the lens would be, straight in one direction towards the center base station. And if you can imagine, this paper towel roll here is the receiver. Of course, the receiver will be much smaller. With that really straight beam of IR combined with a very small tunnel from which to receive the IR, like so, you should get pretty discernible signals from each station. If you can see, well, you won't be able to see the lights, but here I'll focus in on the computer screen. We've got a little program running here. There we go. And there's really no way to get this, but right now I'm pointing directly into the tube, and you can see data flickering by. If I come at an angle to the tube and I'm fairly close, well, I can't see, yeah, I'm inches away, it's still getting reflected data in there. Even at it's not until I get practically outside the tube that it stops. Now if I walk back to, say, over behind this piano, there you go, watch the data flickering by. I'm pointing directly into it, and I'm still getting a fair amount of signal. But if I angle up, say about 45 degrees, it goes away. And this is about at a 5-foot distance. If I pull it back, pretty straight on, I can't see necessarily. Yeah, okay, so I've got about a 30-degree range of motion with something as long and as wide as the 22, maybe about 20 degrees. And as I move further back, I've got maybe a 10-degree range of motion or less. It's hard to tell, I have the piano on the way. So about 10 to 5 degrees at a distance of about 10 feet. So using that, I should be able to space them evenly enough to, should be able to space them evenly enough to get a good clear signal and get one that's differentiable from the other stations.